Hello, math class. Welcome to math. I've decided to record the lessons. That way, you guys have a method for going back, retracing over things, reviewing things that we've covered. You can kind of go at your own pace when you're taking your notes, and we're not waiting for everyone in the chat room. When we're in the Zoom meeting, I'm kind of going to use that for a time to ask questions, get some help, um, just general kind of classroom stuff. So we're going to start our new unit today. The new unit is going to be centered around that topic I've been talking about all year, which is factoring. Okay, so um, before we get into the factoring, we're going to talk about some basic operations. First couple lessons are going to be adding and subtracting, multiplying, and dividing polynomials so that you can move into the factoring portion of it. So with that, let's go ahead and get started. The first lesson in this unit is going to be adding and subtracting polynomials, which we've actually done before. If we look back to the very beginning of the year when we were simplifying expressions, we were allowed to combine anything that was a like term. So keep in mind a like term is anything that has the same variable to the same power. We're also allowed to combine constants. So for this first one, we have a negative 2x. So important point here, you want to make sure you put in your notes. That negative sign is tied to that coefficient. So it does make it a negative 2. That's going to be important later when we get to some polynomial addition and subtraction. We're allowed to combine it to this positive 5x and give us a 3x. We aren't able to combine the negative 20 with anything, so it just stays tied to the expression. On the right, we have a 9x and a positive 1x, so keep in mind there is a 1 there, right? So when we add those together, we get 10x. And we're also allowed to combine constants as well. So a positive 14 and a negative 30 would be a negative 16. Okay, so that's where we've been, right? So let's look at where we're headed now. So when we're looking at adding, we're going to talk about addition first. This one will go pretty quick because it's fairly straightforward. I don't expect any troubles with this one. The only time that it gives people trouble is when you have the terms are kind of mixed up and it's hard to tell if something's a like term or not. So what I do to kind of avoid that situation is I like to underline the terms that have the same exponent, same variable. Okay, so for example, if I was adding these two polynomials, so keep in mind terminology, this is a trinomial plus a trinomial, which of course they're both polynomials, but we're going to be adding these. So we're going to take a look at identifying our x squareds first. Now, why do we start with the x squareds? So a good rule of thumb is to just remember that we're going to start from the highest exponent and work our way down until we get to the constants, because that would be standard form. We want our answers to be in standard form as we answer these problems. So let's go ahead and combine these. We've got a 2x squared and a negative 4x squared. They both have an x squared, so they're like terms. So we're going to combine those to get negative 2x squared. And I recommend that you cross them off as you go. It's not really important when you have something small like this expression, these two expressions, because it's easy to keep track of. But if you have a long one, things can get messy and you might make a simple mistake. To be honest, this is the third attempt at recording this because I keep making mistakes. So rather than have you guys witness my mistakes and want a shot, which I can't provide, I'm going to go ahead and re-record this. So once we combine those, we can move down to our next degree, which is the first degree. So 5x positive 6x is going to give us an 11x. And I'm going to cross them off because now I'm done with them. And we have all that we have left is our constant. So we combine those, we get a negative 4. And notice we don't have any like terms left to combine, so that would be my simplified expression. That's be my solution to the addition problem. Okay? So like I said, pretty straightforward. Nothing left to add, so that's as much as I can do. I'm not solving for anything. There's no equal sign. I'm just adding the two polynomials. All right. Let's look at one that's a little more lengthy and might cause some confusion early on. Notice all of the polynomials don't have them in standard form. Okay, so you might not have that luxury, which is where the underlining kind of comes in handy. So if I look, I've got a y cubed and a 2y cubed, and I'm going to be adding those. Okay, so y cubed plus 2y cubed is 3y cubed, and I can cross those off. And then if I look, I only have a single y squared. So I'm just going to bring that down as part of my expression because there's nothing to combine it with. Cross it off. And then I can move to my next degree, which is the first degree, or y to the 1. I've got a positive 3y and a negative 4y, which together would give me a negative 1y, or just negative y. We don't have to write the 1. And then finally, my constants should always be at the end, the tail end of my expression. So I got a negative 5 and a positive 8 to give me a positive 3. And there's my simplified expression. Okay, so addition is pretty straightforward. Not a whole lot of brain work going on there because you're just adding. So don't get this confused with our rules of exponents. We're not multiplying yet, okay, but we will be. Right now we're just adding, so we're just combining like terms. Okay, so gives you the answer. Well, not what I intended, but I've already fixed this twice, so we'll just run with it. So go ahead and, if you would, pause this for a second. Try this on a scratch piece of paper, put in your notes. Obviously, try them both, but the answer to the one on the left is already there. And then rejoin, restart it again so you can see how you did. Make sure you're getting the right idea. All right, so if I'm going to combine those x squareds, that's where we get the 2x squared, right? 5 minus 3. And that brings me to my single x, so a negative 3x and a positive 6x gives me a positive 3x. And then lastly, my constants, which would give me a positive 1. So surprise, surprise, there's the answer, right? All right, for this longer one, this is where, again, I recommend you underline terms as you go. So I'm going to start with the y to the 4th power, right? So again, double checking, yes, this is in fact addition. Won't always be the case, as we'll see in a minute. If we have a positive y4 and a negative 2y to the 4th, we're going to end up with negative y to the 4th. And cross those off. And then my next degree down would be a 2y cubed, nothing else to combine it with. So I'm just going to bring it down as part of my expression. I don't have any y squareds, so technically I have 0y squared, but you don't need to write that. Just keep that in mind for future reference. Just tuck it away in your brain somewhere, because we're going to see that again where we actually need to add that later. But for right now, we're just adding like terms. So we're going to move on to our single y, and we combine those. We get a negative y. And finally, our constants. Combining those, we get a negative 4. See if I did it right this time. Yes, I got the same answer. Good. That was a hassle. And that's pretty much what we're working with when we're doing addition. Now, if I was to, one thing I didn't talk about in this slideshow, which I might as well just mention now, is we can't always, well, I'm not even going to say that. Well, what we need to watch out for, I guess I should say, is sometimes we're going to have multiple variables. So we might have like 2ab squared plus, I don't know, ab minus 5, right? And we might be adding that to something that looks similar. And this is what you got to watch out for. Okay, so we might have a 3a squared b plus ab, I don't know, minus 1, right? Something simple. Hopefully you can see how this could be confusing, or not even confusing, just it might catch you if you're not paying attention. So you might see these and go, oh, I'm in a zone, I'm just adding, easy peasy, but these are not like terms, right? They're not like terms. So we can't combine them, right? We have an ab squared and we have a squared b. So not allowed to combine those. So I'm going to put them in standard form, which means the a squared b goes first alphabetically, right? and then 2ab squared. Can't combine them, but I took care of them. The only like terms we have are the ab's, so that's going to give me 2 ab's, right? 1ab plus 1ab. And then finally my constants, combine those, I get -6. So just something I wanted to mention because you're going to, run across problems that are trying to trick you. You just want to be careful that they are the exact same variable to the exact same power. Okay? Otherwise, you can't combine them. All right, so let's take a look at subtraction. Now, subtraction is where you want to be careful, okay, because it does tend to mess people up. They can be a little tricky. All right, so remember that the minus sign applies to the entire polynomial that it's in front of. Okay, there's that imaginary, not even imaginary, it's just not there. There's a -1 outside of it. Okay, so when we have a problem where we're adding two polynomials, or sorry, subtracting two polynomials, we have to keep in mind a different color. We have to keep in mind that this is a minus sign. Okay, so this minus sign applies to everything inside this polynomial. All right, so this is where signs really become important here, because if we're going to start out by combining our x squareds, we have a 2x squared minus a 3x squared. Okay, so that gives us a -x squared, or -1x squared. Okay, and then we move on to our single x terms, -2x minus 4x. Okay, that minus applies to the 4x as well. So -6x. Then we move on to our constants. Right, so watch what happens. We have 3 minus a -5, which obviously means 3 plus 5, which is going to give us +8. Okay, so big thing to take away from that is that that negative sign does apply to that whole entire trinomial. Okay, it applies to the whole thing. So we just got to remember to subtract anything that's in there. Now, alternatively, what you could do is a little shortcut if it makes it easier to, work with. A lot of people do this. If you were to change this sign to a plus, you're allowed to do that if you change all of the signs of the coefficients inside of that polynomial. And then you're just adding like before. Okay, so it's up to you, whatever you prefer. If you like to think of it as distribution, that's fine. If you want to change all the signs and make this operation a plus, so it's easier to keep track of, that's fine as well. Just be careful. All right, so there's another answer for you. So go ahead and pause this, try this on your own, see how you do, and then I'll work through it with you to see how you did. All right, so check your work, see how you did. 6x cubed minus 4x squared plus 6x minus 2. Let's check my work because now I don't trust myself at this point. We've got a 4x cubed and a -2x cubed with a minus sign. So it's actually 4 minus 2, which gives us +6x cubed. Takes care of those. Working down to our x squareds, we have a -3x squared minus x squared, right? So that's a -4x squared, which is what we have in the answer. I don't have any other x's, so that's just a +6x down there. And then finally, our constants. I have a -4 minus a -2. In other words, -4 plus 2, which is where we get our -2 from. Might as well check my work on the one on the right. So we've got a minus sign here. I only have a single -y cubed. So it's actually a +y cubed because it's negative, right? Looking at my x squareds, I have a +5y squared and nothing to subtract from it. So I'm just going to bring that down to the answer. And then our single y's, 8y, and a +12y if we subtract them, right? It's 8y minus 12y, so negative 4y. And a negative 10 minus 7 is going to give me negative 17. Okay, so subtraction, again, it's not that difficult. The tricky part is when it's subtraction because you got to keep track of those minus signs. All right, so just something to think about. Okay, you're going to expect some word problems with this, so just remember what the topic is. The topic is addition and subtraction. And then once we have an expression, sometimes the follow-up question is evaluate the expression, right? If we evaluate the expression, that just means you're plugging a number into the variable to see what you get. All right, so for this one, we have these two equations, P equals 7m plus 137 and C equals 4m plus 78. They represent the number of cell phones, which is the P, and digital cameras, which is the C, sold in M number of months at an electronics store. Write an equation for the total monthly sales of phones and cameras. I think the one I stole this from is, shouldn't say equation, it should say expression, right? Because we're not actually solving anything yet. So if we were to write an expression showing their total monthly sales of phones and cameras, all that means is we're going to take what the function is equal to, or what the equation is equal to, and add those, right? So 7m plus 137 is the phones, and if we add that to the cameras, 4m plus 78. All right, so go ahead and combine our like terms. So in this case, 7m and 4m gives us 11m. So remember, m is months. 137 and 78. I didn't bring a calculator with me, so just do real quick here. 5, 1, 215. Should be right. I'm sure if I'm wrong, one of you will email me. I guess we'll just keep a tally on these on these videos. Whoever is the first to email me a mistake I made gets a shot when we return. Maybe we'll do one of those shots for points exchange programs. We'll see how it goes. So this is my expression that represents the total, right? The total of the phones and the cameras. And then the second part of this question says to predict the number of phones and cameras sold in 10 months. So in other words, when m equals 10, right? So plug those in, we get 11 times 10 plus 215. And order of operations says we multiply first. So 110 plus 215. They can probably expect to sell, what would that be? 325 total cameras and phones. Nice. All right, so we change this a little bit. So it's the same scenario, right? Still have our phones and cameras, same equations and everything. The difference here is that it's asking, literally, whoops, sorry about that, literally for the difference in monthly sales of phones and cameras. So we're going to subtract them now. So same problem, setup. The only difference is we're finding the difference between the two. So it's a minus. Right? So still combining like terms. We have a 7m, but now it's minus 4m. And now comes the fun part, right? Subtraction on the fly. I'm not even going to try it. So 0.12. And can't even think. 12 minus 3, 99. Check my work. Okay, so 3m plus 99 is our expression that represents this, right? So if we were to evaluate this expression in 24 months, that means our months is 24. So let's plug it in. 24 plus 99, 3 times 24, 12, that's 70, 72. 72 plus 99, we get 171 phones, right? It's the difference in their sales. All right, so that's about it. Like I said, it's a pretty straightforward lesson. We're not getting into anything super difficult yet. Here is the assignments for each of the classes. So if you're non-honors, you're going to do workbook page 93 if you brought your workbook home. If you did not, I'm going to post a copy of the digital version, which is page 97. You can get to that as well. Make sure the title says 7-5, adding and subtracting polynomials. That way you're doing the right one. And then for the honors class, I have two handouts for you. Those will be on PowerSchool, so just download those. I don't care how you guys do this. You can either bring it into Notability and do your work on Notability and then just send me the PDF when it's due. I'm still going to keep due dates on Monday because I feel like you guys got enough on your plates without having to change how we do the bulk of what we do in class. So everything's still going to be due on Monday. So keep that in mind. I'm also going to post the answer keys on my main PowerSchool page. It'll be on the right-hand side underneath the unit outline. Okay, you'll start to see the keys populate there. So what I recommend you do, go through the problems as normal, just like you would in class. Do a few, check the key, make sure you're doing it right. If you're not, try to see where your mistake was. If you're not able to identify your mistake, or if you're having trouble, don't feel afraid to reach out to your classmates or myself. You can either email me. I'll be on my email all day, and then obviously during those quote unquote study times, or whatever's filling the community time right now, I believe all the teachers are going to have their Zoom rooms open. So mine will be open for help, for questions, and also during the math class. Okay. All right, so that's about it. We'll see how this goes for the first day or so, and see if you guys have any feedback for me on how it's working. Hopefully this works out pretty well, and we'll just go from there. All right, have a great day. I'll see you guys in the classroom.